Now let's invite Slavo Hajusa from Eastworks and Srinivasan Krishnamurthy from Madras Mindworks. Thank you.
Hello.
Thank you.
Thank you. So myself, Srinivasan Krishnamurthy from Madras Mindworks, and my colleague, Slavo, he can introduce himself, yeah.
Yes, so we have a presentation together. I have the first part, so I might just as well start. So XWorks, Interactive Experience Works, is a company which is based in Slovakia, which was founded in 2014. Slovakia is a small country in certain Central Europe. It's so small it wouldn't fit on a slide. And actually, it's smaller than any city I have so far been in India with 5 million citizens. But yeah, here we are. So our mission today is to talk about our path, which heavily involves getting industrial source 3D data into high-end VR and augmented reality presentations. So a couple of words about us. Our origins actually are in the gaming industry, and it was around 2014 when we switched to more serious applications. We are using Unity in all of our development and customer tools, and over the years in the gaming industry we used a couple of engines. We were there even before Unity really took off, and we collected a large 3D competence and expertise and competence with a lot of hardware platforms. So that was sort of the base where to start with XWorks. The company at the moment has 12 core team members and a group of freelancers. So we develop solutions directly for our customers, and we also develop software tools about which I will talk in the main part of this presentations. So, as it's pretty much obvious, especially on a conference like this one, we are ongoing a new development, a shift, a transition in media communication, which is in relation to the augmented and virtual reality world, a shift from two-dimensional to three-dimensional media. It's only 3D which really makes sense in virtual reality, and it's a trend which is very much obvious. The prospects for the augmented and virtual reality developments are huge. The whole industry is expected to grow by multitudes every year until 2020. And so far these growths are actually pretty much happening. So it's not a bubble, it's real. Virtual reality and augmented reality is definitely coming. But the position where we are now with the hardware, especially the hardware of the past 2 years, is comparable to early mobile phones. So we have hardware which is connected with cables, we have to place sensors around rooms and so on. So it's still quite a difficult configuration, but the upcoming hardware is much better, and there's so much coming that it's pretty much clear that the technology will evolve. The probably main trend, especially in industrial use, will not be full-scale virtual reality, but will be mixed reality. Headsets where you will be able to see the environment through and have augmented 3D and user interface components blended into your view. Or helmets where you will be able to switch between virtual and mixed reality. So the hardware is coming, the hardware is pretty much here. We can develop on a multitude of platforms now, but what is important in virtual reality to really for it to take off is the content. So the content in virtual reality obviously will be entertainment content, video games, virtual movies, and so on. But also there is a huge potential and traction in industrial content. As we have seen with the welding simulations, the industry is really discovering the potential of virtual reality simulation, which is not comparable to simulation on a PC or anything else. It's much more comparable to a flight simulator, which is a huge machine. So this is a great potential which is coming up here. So it's a very interesting position we are in. There are new platforms and new markets opening up. This brings huge new opportunities, and this trend will bring new winners. And it will be interesting to watch which companies and which concepts will be the winners of the media shift to augmented and virtual reality. So XWorks in this field started working directly with customers and sort of proving that our concept of, at that time, cross-platform industrial application is right. And the way how to prove that a concept is right is to sell the concept to a real customer. So over the course of the years, we had customer projects for different industries, machine building industry, automotive, mining industry, architecture, and so on. It's been an exciting time. The drawback of working for the industry, particularly in Europe, is that in most cases you are not going to be allowed to show what you did, because the secrecy surrounding CAD files, developments, and these formats is so high that at the start of every project there is a huge legal NDA to be signed, and you can expect not to be able to show much in at least several months after finishing the projects. But fortunately, we have a couple of partners which have, in a friendly way, allow us to show what we produce for them. And one use case, just to illustrate what kind of projects we are doing, is here with an automotive. If we could have the camera on the tablet. Yeah, perfect. So in this case, this is a cross-platform application. I'm showing it here on an iPad, but the same content works on a PC and also works in virtual reality. In this case, we have an interactive manual for a track day car, which tells us how to set up the car for driving, and it tells us also what to do about diagnostics. So the solution we developed for this partner includes communication with the target machine, with the car, which transfers the diagnostics to the iPad. And then the iPad tells the user which parts will need replacing, which parts have to be ordered. And then, once everything is ready, it also talks him through, virtually, through the process of how to operate and perform maintenance. So many maintenance operations to be done on the car are shown here in 3D and can be experienced step by step. So in a lot of cases, this are the projects which we are doing, projects where we do maintenance cycles, instructions manuals, visualizations of repair cycles and things like that. We often also connect a feature called Guide Link, where actually you can connect to the support for this product, and the support that can then screen share with you, and they could take over the 3D and explain you in 3D what you are supposed to do to get out of the situation. So, and as you see here, this is a project done in Unity, and we have the whole car basically here in an iPad. So it's pretty obvious. Thank you. And we can return to the PowerPoint. It's pretty obvious that these are no CAD files from the car designers running on an iPad. That would not be possible. So in doing these projects, we very quickly saw what kind of bottlenecks we will be experiencing. And one of the key bottlenecks was, when working with the industry, to get the industrial data to really run in true cross-platform environments, because while virtual reality can be performant when you are running from a powerful PC, often you are not. You're running from a notebook, or you have to be in virtual reality, but also on a tablet. So you have to get 3D data output, which can run in Unity on these platforms. And that was one of the largest bottlenecks we had. As said, the projects we covered were interactive presentations, portable instructions, maintenance and training, but the topic was always the same: how to get the 3D data quickly into the target format, and also to fulfill quality requirements, because the user, the customer usually demands the highest possible quality. And this is what we saw as the upcoming and the main challenges: the content experience and the quality. I mean, at the moment, it is sometimes possible to get off with a low-quality virtual reality because it's a new media and everybody's excited, but very soon it will be required to have realistic, photorealistic, highest possible quality. So the task and the challenge is, how do I get this quality? And the second challenge is efficiency and scalability. An industrial partner may want an early pilot project, and that's usually how a story starts, but afterwards, an industrial partner doesn't want a 3-month project for each of his product. That's not efficient. An industrial partner will always be looking after a pipeline which can be quick and efficient. How could I get 20 products, 50 products, hundreds of different versions of products into that new media? So scalability is a huge topic. So the project I have shown, the car manual and maintenance guide. The base of that project were CAD files which had the size of several hundred megabytes. And at that time we were working in a pipeline, basically the usual pipeline. So we had to use one software solution to open the CAD files and separate them into smaller subgroups, because importing 300 megabytes of CAD files into, let's say, 3ds Max didn't really work. There were too many issues, too many fragmentations, and so on. So first we had to use software 1 to prepare the CAD files. We could ask the industrial partner to do it for us and tell them, okay, 300 MBs, that's too large, give it to us in 5 60 megabyte sections. But that's not really solving the problems. That's actually annoying our customers, because we are telling them to do a part of our job. That's not something they are going to like. So we had to do it on our side. So we did that as step 1. Then we had to convert the CAD format files into a mesh format, into an FBX file, basically. So we did that, usually ending up with a very complex FBX file with all the CAD data input converted, which means that every single bolt and every single screw is there with all the windings and everything with details you are not going to need for the project, but to have an overall level of detail, you have to take that into account. And the third step was to manually adapt the output to the needs of the application. So for the application, for example, we need 200,000 polygon mesh for one station. So we had to check, okay, the station, these parts will be in. We have to have everything under 200,000 polygons. And an artist had to start looking manually, okay, I can reduce this, I can cut out that, so on, so on. A very tedious process, which took a lot of time and a lot of human effort. On the car and the application, this translated to about 6 man-weeks of a rather good professional artist. So a lot of time and a lot of costs, both very negative factors for the customer. Sometimes the time actually is more of a factor than the cost. Some manufacturers can afford to pay people, but they want the output to be ready in 2 days, not in 6 weeks. So we had to face these challenges, and it was very clear to us that we had to do that. And at that time, and even today, we didn't find solutions on the market which would do the process for us. So in our team, from the start on, we set up with a very competent team of software developers and programmers. We decided to, in a course of 1.5 years, develop a tool for 3D graphics optimization. The tool is now in a trial stage and can be downloaded from our homepage. It's called Optium 3D. And its current purpose is to create a bridge between CAD file input and Unity engine. And by meaning bridge, the tool has to walk the line between automation and human input. One of the key factors we also experienced in every project was that every project was unique. There was no unified one way how to do things. Some projects focused on the surface detail. Other projects focused on surface plus some part on the inside. Other projects focus on things which are entirely on the inside. So there had to be a kind of a human interface to specify what exactly will I need in what quality. So the approach we have chosen for Optium 3D is pipeline-driven optimization. That means that the tool basically consists of a viewer where you see where your output data are going, and a pipeline part, a map on which you put nodes, and each node fulfills a purpose and does something with your data. You can create a pipeline, and when you are happy with your pipeline, run multiple sets of files through the pipeline. So that's when the real multiplication and automation sets in. I'll give you an example of a project, how exactly this is used to get from CAD source into Unity. So on this screen you can see the input node and the input file. This is a step file, common CAD format. On the left with the yellow dots you see the parent structure of the CAD file, which is displayed. So you see it consists of several hundred submeshes, which is also a problem, or sub-objects, which is also a problem. So what we see instantly we will have to do on this one to get it into Unity, we'll have to transform it into a mesh format, we'll have to reduce the number of submeshes, and we'll have to add normal maps and add UV maps to be able to add on materials and make it look nice in Unity. So the first step we can take is to create groups. Still in the CAD format, we can assign different objects and different groups of objects into optimization groups. If I know, for example, that the tire and the wheel is super important for my project and has to have absolutely one-to-one realistic detail, I can assign it into one group, and within that group I will parametrically tell it to keep maximum possible detail. So we will have non-linear optimization between groups. I can pick out the important parts into high-level optimization, and the rest will be the rest group, and I'll just assign 20%, 50,000 polygons, whatever I want for the rest, which allows me to focus on the parts which are really important, which is, again, the key to achieving high quality. If I would just automatically convert the files, I will get a rounded up summary level of detail on the whole thing. So either I would have to separate and convert 10 different files in some software, or I will have to accept a global level of detail. In our software, we can individually assign the level of detail according to the needs of our project. The next step, the next step is going to mesh. So this is our wheel, and this is the initial conversion to mesh. This is a relatively still complex mesh, but it's a good starting point. I see I've got a mesh. I can view the mesh in several different forms. At the moment I'm viewing it as the wireframe, but I can view it as a surface, I can view it as normals, and switching between these views, I can find out my sweet spot level of detail for the converted mesh. So if you look at the picture most to the left, that's the highest level, that's the original level I started with. I checked what still looks good as a surface, and the middle mesh is the output which is okay for me. So through sliders and simple experimenting, I can reach the optimum level on this object group. This is repeated. Object groups are created, and each group is assigned its relevant level of detail. In the viewport, which is there on the right side of the Optium 3D interface, I can switch between different views. At any stage, I can view my output as a wireframe. I can view it as an infrared scan, showing me internal details which might be hidden on the surface. I can view if the normal maps are fine. And according to the interim situation, I can decide upon my next steps. The nodes I have, as you see there's a couple of nodes there, offer me different functions. Some just reduce complexity, but there are also functional nodes for frequently requested functions. Frequently requested functions, for example, could be closing openings under a certain size. So if I know I will be looking at something from a distance and I will never see holes which are under the size of 2 millimeters, I can create a close holes node and close them, so I get an even mesh and much less detail on a surface which previously had holes. Or if I know that a certain object will only be seen from the outside, I could put in a skin node, which will just check what is visible on the skin and cut out everything else. So if I had bolts protruding through the inside and windings and things, they will be automatically cut out in one step, and I just get a simple object seen from the outside. This all contributes to a lot of time saving. So, when I'm happy with my poly count and the complexity and level of detail, I do the finalization part, which means rebuilding the normal maps and adding UV coordinates for materials in Unity. Again, I can at this stage collapse meshes into the number of submeshes which I need. So in this case, we started with several hundred sub-objects in CAD format, and we finished with 30 submeshes, all with normals and UV maps, ready to be imported as NFBX files with these data into Unity. The time savings on this side of the project can be 75%, well over 75%, even up to 90% of very complex CAD files towards the standard procedure used before in the project. So, and not least, the positive side of Optium 3D is that when I know that my project will be used on several platforms, and I know the requirements, I know that for the iPad side, my limit is 200,000 polygons. For the virtual reality, I may lift that to 2 million polygons. I can create several LOD outputs and create staged levels of my project. Also, when I find out at a later stage, perhaps in Unity, that I've done a mistake somewhere, I can return to the pipeline, and I do not just have a source file, an output file, but I have all my work in the pipeline in Optium 3D. So I can return to precisely the point to make the change it, let it run, there's the output. So it saves a lot of time and nerve on this side of the process. So now we are in the Unity environment. Here we see the starting point, so this is the object structure. I have 30 submeshes, a number Unity will be extremely happy to cope with, even on smartphones and tablets. And I start adding materials. So I select objects and add materials. Here you can see that the UV coordinates created in our software are sufficient to depict simple materials, linear materials, so I can have plastics, leather, metal, and it will look reasonably good. It does not create unwraps used in games, for example, so it wouldn't be possible to map faces and things like that, but it's very good for material and tiling texture application. So this is one shot seen from a more distant perspective. On another shot, you see a relatively complex structure of the roll cage of the car, which is from complex pipes, and is collapsed into one mesh. And you can see that even on such complex structures, the UV mapping and the material displayed in Unity still has reasonable quality and can be immediately used in this way for an industrial application. So that's what we did, a bridge between source CAD files and Unity usability. And in that bridge, we reduced the time, as said, by 75 to 90%. Unity Optium 3D is now available, so anyone interested can download it and test it from our homepage. Development is still ongoing, so there will be new features added. At the moment, we cover a good part of the CAD to mesh transformation, so we can go from step file to FBX file quite stably. A reference project we did a couple of weeks ago involved a 3 gigabyte super messy step file, which we were given by one customer, which we converted into a virtual reality application within the course of 3 days, including the application building. So it's up to the task for really complex situations. And the next steps in our development will be, of course, adding more functionalities, adding more use cases which you can automate in Optium 3D, and also adding other input formats. At the moment, as said, it's CAD in step format, and of course you can start with a complex mesh and just reduce it to different lots. We will be adding point clouds in the near future as well, so 3D scans will also be a possible source of data for Optium 3D. And we hope this will open new levels for its use. So that's about my part. Thank you for listening. I pass over to my partner.
Thank you, Slavo. Good evening, everyone. So I'm from Madras Mindworks, creative technology company. We provide AR/VR solution for enterprises. And when we start this company, everyone thought that working with the AR and VR technology is too costly. That was a myth. Actual reality is it reduces the infrastructure and the training cost, and it helps a lot of enterprises. And so this is the enterprise adoption rate. How many companies are willing to adopt AR and VR technology within next 3 years? Actually speaking, 48% of the companies are ready to adopt this technology of VR, and then 67% of the enterprises are ready to adopt AR within next 3 years. So what are the industries mainly focusing and which will be helpful for them to getting into this technology? Marketing, it can be used in marketing, retail, sales, medical, tourism, industrial training, education. So there is a lot of scope and application for this. So what is the most important thing over here is content. Yes, content is more important. There are a lot of tools, and Unity is the best tool to create a lot of content and interactive and most interactive content. But on the market side, which is more important is the context. We need to understand the client requirement and the client, what is the exact context to be delivered into it. So contextualization is more important. That's where we specialize in. We understand the client's requirement, and accordingly we create the content and provide it to them. So industrial application at glance, and actually if they can be used in the 4 domains, one is the immersive learning, and the best example, you just saw the Skillberry. We are happy to be a part of that project, and which is a building simulator, which was very interesting and challenging one. And there is a lot of scope in the immersive learning in enterprises or education sector everywhere. It gives you much more, the experience gives you lot of things on it. And then this will also enhance the consumer product. The one which we are working with right now is the sanitary ware products, and then the furniture companies. They have started using AR and VR. And latest news is that Amazon started showing the AR for their Amazon products, where we can just put on any of your furniture and see it in your home anywhere before buying it. And then we are also working with the tourism industry, the Rani Ki Vav, which is placed in Gujarat. We are showcasing the entire thing in a 3D monument. And here comes the helpful tool for us is the Optimum 3D, where we scan any sculptures and the monuments. There is a lot of meshes, and the Optimum 3D actually we reduces this measure size, and it was very helpful for us to get into a VR part. And then the design and analysis. This is much more important. Automotive R&D sector in design and engineering. There are a lot of things can be showed here. Just a minute. All right, so I think I can show it here. In automotive sector, everything we are creating in 3D. But all these days we have been seeing all this 3D content in a 2D view. But here we have a AR and VR technology where actually we can get into the 3D very immersively, and it will be very useful for design, iterative, and real-time changes, which will helpful and save a lot of time. So that is the best part over here. And yes, this is our team, Madras Mindworks, so 4 co-founders. So what are the main challenges over here is in Indian market is that there is no standard workflow for VR projects. So we are trying to bring a standardized pipeline method for VR projects, and that's where the Optimum 3D will helpful for many of them. And this will be the one of the tool to convert the raw industrial data into export into a VR, AR, or anything. So this will save a lot of time to it. And this is one of my favorite saying from the Walt Disney. You can design and create and build the most wonderful place in the world, but it takes people to make their dream reality. I think all together we can be those people. Yeah, thank you so much. So Slavo, please. Question time? Yeah, hopefully answers.
Yeah. So
the Optimum 3D is only supporting STP or STP, right? Any other importing formats?
at the moment, we are only supporting step file because it can be exported in almost every usable software. But in the future, we are planning to extend to a multitude of CAD formats. So we had to start with something, and the step file was a starting format. It's anything but perfect, but it's a start, but it's not the end.
Okay, thank you.
Hi, I have also one question. When we convert these files, CAD files from any other CAD software to the mesh, does it maintain the hierarchy? The way the CAD modeler has maintained his hierarchy, the assembly, I would say. So when you transform this into the mesh format, FBX or anything, does it maintain the same hierarchy? Because most of the times when we convert, we lose the hierarchy and it does not get converted the way we want.
Yes, it does. It does potentially save the hierarchy. So you can have up to the full hierarchy of the original CAD format, which usually will be far more sub-objects than you want, but you can, yes.
Okay.
Yeah. So there are nodes which can split and merge these hierarchies, but you do not have to use them.
Okay. Thanks.
Yeah, hi. So you mentioned about the grouping of the objects and different splitting. So how far we are from automating the entire process?
Sorry?
So you need some human intervention to do the groupings of the objects, right?
Yes.
So how far we are from the automating the entire process from CAD to FBX file directly without any human intervention?
How far? I'm sorry, I'm not hearing this really well.
The audio is audible, right? Okay. So I'm asking that we take the CAD file and we try to convert into FBX file format, right? Now in between there are certain steps are done manually by the human. So how quickly we can move from removing those things altogether and have a process which can automatically convert an CAD file to an FBX file?
Okay, as far as I understood the question, there are several ways to handle these groups and objects. So you can do it per object. You can select the objects in the step file structure, which is, it imports everything which the step file provides. So if there is a naming structure in the step file, you can see the naming structure, and you can find by name whatever you want to find. You can check what is visible, parents and sub-objects. And you can also check it on the viewport. So you can select objects and group on the viewport. So that's single object selection. You can also use volumes to select groups of objects. So you can create a box volume or a cylinder volume, and everything which is inside or which protrudes into the object you have created, into the volume you created, is selected. Or you can go by the criteria of the input file, which is basically check if something is on the surface or if it's not on the surface. And then you can decide, do you want to create a new object? Basically, if you have a screw which is protruding the surface, then you have the surface part of the screw and the inside part of the screw. One way to do it in Optium is a cut, where you lose the screw as an individual object, but you get the surface, and everything which was below the surface is deleted. The other approach is object identifier, where you can, for example, set the criteria size and look what objects are under a certain volume. You get highlighted in a contrast color. In this size, these objects fall under the size. And then you can remove or put into a different group all objects with these certain criteria. Does that answer at least a part of the question?
yeah, a bit. So when you say we select, so in our example, we had a tire of a car. That was forming a group, right? So somebody has to select that this is the parent and this tire is becoming one group.
Yes.
Yeah. So is there, because a lot of things are going on, a lot of development is going in AI field as well. Can we have something, or how far do you think we are, where we can have algorithms which can automatically create groups without human beings being selecting this is the tire as a group, or different parameters where, where we don't want the bolts part or the screw part, based on just the number of polygons we want, can directly create an FBX object from the CAD file itself?
Yes, yes. That's a very good question, and we are walking on the edge here. Like, there is a perfectly fine possibility for automation, but at the moment we are more working on the manual side and gathering experience from our customers. What kind of functions are they using into what way to be able to offer meaningful automation? So we are gathering the data, and once we see that in 90% this type of input is used and this type of node is used, then we will move on to automating these processes. So it's technically possible, but we do not feel to have enough data from real projects with real customers to force automated pipelines, because that's...
But I think it can be automated if it's something like same process has been used regularly, every time. Then we can automate, right?
Once you have your own pipeline, you can run more objects through your own pipeline. So you do not have to create a pipeline from scratch every single time.
Yes.
If you have 20 more or less similar objects where you want to apply more or less the same criteria, then you can just have a pipeline, let them run through, and maybe just check on the node if it's really doing what you want it to do. But really, automation is a big topic, and we have plans. We have plans also for machine learning, but at the moment, it's not in the current version. It's a midterm future of our tool.
Yeah.
Thank you so much.
All right,
Thank you.
I think we'll just have one last question before we end.
Yeah. Hi. My question is to Srinivasan.
Yes.
Can you slightly elaborate more on this Raniki Wow project? Because you mentioned that this Optimum 3D has helped you, and I suppose this is done through range scanner, laser scanner, right? But as he mentioned, Optimum 3D does not support point cloud data.
No, it's not a point cloud. Actually, it reduces the meshes.
It does, but it's not in the public version.
Yeah.
So with our direct
not in
partner,
the
this
public
was a
version.
part of an experiment.
Yes.
It showed that it can be used, but it also showed that it's not ripe to go to the general public yet.
So actually in that, the part of the thing is like we built it in a CAD file, and then the remaining thing was mainly the sculptures are scanned, but the entire monument was built through CAD files. Yeah, we just imported from there, and in the pipeline we used the Optimum 3D over there. Yeah.
Okay, thank
Yeah.
you. Thank you, Slavo and
Thank you
Srini.
very much.
Thank you so much. Thanks.
It was a
Siriji,
pleasure
and
being here.
It's been a great crowd. Thank you.